Now this illustration deals with the grounded conductor. Now if you have reviewed 250.30, starting with the very first figure that outlined 250.30, the informational note, notice that we have broken down 250.30 and gave you as much information as we possibly could, but we have attacked each section here, and such as now this grounded conductors NEC 250.30 A3A is an apple, and now we're talking about the grounded conductor. Now notice that the grounded conductor, if you had, say, installed a rigid non-metallic conduit between the transformer and the panel board and routed your conductors through that non-metallic raceway, and you know, naturally you would either make a 10-foot tap, a 25-foot tap, over 25 foot to 100 or any length you want. But we would be looking at 240.21C as in car for commercial and industrial taps, and for supervised industrial locations, remember, we would review 240.92. Now, reviewing this grounded conductor, notice again, we're kind of a little repetitious, but this is so important. Now, notice the note. 250 kc mil secondary conductors requires 2 AWG copper per 250.30 A3A, because we are using our table 250.102C1. Now naturally 250.102C as in car 1 refers us to that table. So 250 kc mil terminating in the main, in the panel board. Then notice that grounded conductor would have to be at least number 2 based upon 250 kc mil, and we're selecting the number 2 copper based upon those size conductors from table 250.102C1. Now, notice that's just an effective ground fault path that 250.4A5 calls for in the NEC. Now, you still have to look at it to see if it's neutral load. And if you have neutral load, then it would be calculated, but you would use the largest size conductor, either from calculating the neutral from 220.61 or the grounded conductor to serve as an effective ground fault path from table 250.102C1. And then if we kind of focused on the grounding electrode conductor in accordance with 250.30A5, then notice it too would be number 2 if connected to structural steel or to a metal water pipe that is an electrode in accordance with 250.52, A as in apple, 1. But notice the structural building steel is discussed as being a grounding electrode for a separately derived system in accordance with 250.30A4 item 2. Now notice here, we've removed the XO. That's very important in the transformer. The XO connection to the metal enclosure has to be removed if we're grounding at the service disconnecting means, or I shouldn't say service, but the panel board disconnecting means, as you see there. Now, notice since we're connecting to the structural steel with the grounding electrode conductor from table 250.66, based upon 250 kc mil, it would too have to be number 2. If we should have a supply side bonding jumper bonding the conduit in, it too would be number 2. The system bonding jumper, if you added a conductor to supplement maybe a screw in that panel board that bonds the bar to the enclosure, it too would be number 2. You couldn't put number 6 or number 8 and be in compliance with the code if the authority having jurisdiction called your hand. by using a smaller size conductor. If the authority having jurisdiction okays it, then you know that's something different. That's a 90.4 decision of the authority having jurisdiction. But notice you do not need to add a conductor if you had a screw, if it's a newer panel that you're using, then it would be naturally green in color and you could see it. If you happen to be troubleshooting an existing job, well, that head may be a different configuration, or you wouldn't have any conductors underneath that particular screw because it's bonding the enclosure to the grounded bar where you would connect your grounded conductor, all your neutrals, and your equipment ground. So this illustration is strictly dealing with the grounded conductor when it's being used as an effective path for the fault current to travel over in accordance with 250.102C1 as well as table 250.102C1. But we're talking about this grounded conductor in accordance with 250.30A3A as in Apple. And this figure 16-39 is illustrating the grounded conductor where it is being connected to ground to the structural steel at the first disconnecting means between the transformer and the panel board.